Algebra arises in many, many places. And an absolutely fundamental place that algebra arises is in the study of symmetries. Here are some objects, physical objects, they're solid. And a symmetry should be something, a transformation of this that leaves this solid property unchanged. So let's fix it in this position here. So here is a rotation. We want this to see this face here at the front again, but not necessarily this exact copy of a face, just something that's indistinguishable as far as the overall geometric object's concerned. There, that for example. Now not every object has the same number of symmetries. So here's a different object with fewer symmetries. This thing here to me is a very, very beautiful structure, but it almost looks kind of random when you look at it. It has no obvious symmetries. I can't choose an axis and then rotate it and get something that looks the same other than just a full 360-degree rotation, for example, which really isn't doing anything. Think of driving a car down a street. If you do a U-turn, well, that's doing something. But doing a 360-degree turn, you're back in the same place you were to start off with. And this particular object has no symmetries. It's kind of devoid of interesting properties from that respect. So the study of symmetries turns out to be extremely important in mathematics. And the symmetries don't have to be of actual physical objects. It could be symmetries in solutions to equations. Everywhere where mathematics applies in real life involves solving systems of equations, or at least just about everywhere. And understanding the symmetry of the possible equations turns out to be absolutely fundamental. And this is in fact the origin of the study of symmetries, is not so much in the study of physical objects like this, but in a much more abstract notion of symmetry. Here symmetry just means we have some objects and we have various properties we're interested in, and a symmetry is some transformation of those objects that leaves the properties unchanged. Symmetries of networks, for example, pictures that look a bit like this, where we have various nodes connected in unusual ways. Pictures like this could be a network of computers, or it could be a collection of people who know each other, and these edges represent the way that they know each other. Symmetries of objects like this, again, reveal very many interesting properties of the connections between such situations and have important applications in things like coding theory. Coding theory is used everywhere. When you put a CD into your CD player, whenever you transmit information, it has to be coded in terms of zeros and ones, and efficient methods for coding and robust methods that can withstand some interference along the way, are all related to objects that are highly symmetrical. So the study of symmetries is an important place where algebra arises, and it's certainly nothing like the algebra of numbers.